Hello, this is question 15 on your AQA June 2019 AS paper. You have a tractor and its driver have a combined mass of m kilograms. The tractor is towing a trailer of mass 4m kilograms in a straight line along a horizontal road. Tractor and the trailer are connected by a horizontal tow bar, so something that is rigid. We have a driving force of this value, resistance force is 160 in the tractor and 600 on the trailer, and we know the acceleration, so the acceleration is 0.8 meters per second squared. First thing we have to find is the mass. So if we have our tractor here, so let's say this is the tractor and this is the trailer. The tractor mass is m, the trailer mass is 4m. We have a horizontal driving force of 11,080 newtons, so in the direction of the tractor, so 1180 newtons. Resistance force is 160 for the tractor, so against the motion, and 600 newtons for the trailer. And they are moving with an acceleration of 0.8 meters per second squared. Yeah. What we are going to do is, we are not interested in the tension here, so because we will have a tension in the tractor, in the trailer that is that way, and a tension in the tractor that is that way. If we don't want to find the tension, what we are going to do is to work with both particles connected. Remember, when we have connected particles, we can work with them independently or with them both together, like if they were just one thing. So that's what we are going to do, and we are going to apply the equation of motion. So first is going to be mass acceleration, and we are going to work like if this was one whole thing. Yeah. So forces in the direction of the motion is going to be 11,080 newtons. So 11,080 newtons minus forces against the motion is 160 and 600, minus 600 minus 160. So this is the resultant force. Is going to be the total mass combined of both of them, so 5m times the acceleration, which is given. Yeah, and from here, very easily, I'm going to find the mass. So the mass, or the value of m, is going to be 2,580 kilograms. They are asking us m, yeah, the value of m. So we don't need to find the mass of the trailer, for example. So this is the answer. The next part, they say find the tension in the tow bar. So that means now we need to work with the trailer or with the tractor. It doesn't matter. We are going to get the same answer. So I'm going to get the trailer because it has less forces than the tractor. So if we isolate the trailer, I have tension in this way, in the direction of the motion. Remember, this is moving with an acceleration in that direction, and 600 newtons in the opposite direction. If I apply again the equation of motion, so force is mass acceleration, my resultant force is going to be T minus 600. So T first, because it's moving that way, so this one is greater than this one, is mass that I know now is going to be, so m is 2,580, but remember the mass of the trailer is 4m. So the mass of the trailer is 4 times this value here, which is 10,000. So the mass is 10,320 kilograms. Yeah, so this is what I'm putting here. Not the 2,000, but the 10,000, which is the trailer. 10,320 times the acceleration, which is 0.8. And from here, the tension is 8,856 newtons. Yeah. So this is the tension in the tow bar. If you use the tractor instead of the trailer, you're going to get the same answer. And the next thing they ask is, at the instant the speed of the tractor reaches 18 kilometers per hour, the tow bar brakes. Total resistance for acting on the trailer remains constant, and starting from the instant when the tow bar brakes, calculate the time taken until the speed is this one. So we are introducing now time and velocity, which means this is going to be a constant acceleration question, because our acceleration is going to be constant. It's going to be a deceleration between the 18 kilometers and the 19 kilometers, and it's going to be constant because the forces are not going to change. So we have a situation when we have our truck, the trailer, because the trailer is the one that is going to stop. I have a resistance force that is still the 600, but I don't have tension because this tow bar is broken now, so I don't have anything here. So the tractor carries on, and the trailer is still slows down. Yeah. So the initial velocity is this one. The final velocity is this one. So I'm going to apply suvat equation, and for that I'm going to write suvat, and I'm going to write what I know. We don't need the displacement, and they don't ask. Initial velocity. Remember, I'm going to apply suvat, but I'm going to use this in meters per second. So the 18 kilometers per hour, I'm going to transform this into meters. So this is going to be meters multiplied by 1,000, and I'm going to transform this into seconds. So this is 5 meters per second, and the 9 kilometers per hour is going to be half, so it's going to be 2.5 meters per second. Yeah. So my initial velocity is 5, my final velocity is 2.5. Acceleration, I don't have it yet, and I need the time. If I want to find the time, I need to know the acceleration. I need 3 things to find a fourth one in suvat equations, remember? So to find the acceleration, I'm going to use the forces equation again. So force, the resultant force is going to be the mass of the trailer times the new acceleration, yeah, which is going to be negative because it's slowing down. So the force, remember this thing is moving to the right. The force, the resultant force is minus 600 because it's against direction, so this is minus 600. The mass of the truck, the trailer, we say it was 10,320 times the new acceleration. And from here, the acceleration is minus 5/86 meters per second squared. It's negative because it's deceleration, yeah? So this is the acceleration that I'm going to write here, minus 5/86. And now I'm going to move this to the side. I'm going to apply suvat equations with these values here. Remember, if I don't want the displacement and I don't need the displacement, I'm going to choose a suvat equation without S, which is this one. V is going to be ut plus, U plus 80. Final velocity is 2.5. Initial velocity is 5. Acceleration is negative, so I'm going to write the 5, the minus at the front. This times t. And from here, t is 43 seconds. Yeah. If you round, or if you divide this number and you round, maybe you get something slightly different, but it will be okay. So it will be marked correct anyway. Yeah. And that's the answer. And this is all with this exam question. End of questions. Yeah. That's all.